Good day everyone. For today's video, we will be discussing the Quarter 3 Module 5, which is all about solving problems involving permutations and combination. Let's start. But before that, let me introduce myself. I am Carl Ryan O. Sales, your student teacher up until the 4th quarter. I am a 4th year student taking up Bachelor of Secondary Education, major in Mathematics at USTP. So here are my personal information. You can contact me through my email address, cell phone number, or through my Facebook account, which you will find at your respective GCs. So here are the lesson outline for today's video. For lesson 1, we will be discussing about permutation of n taken r at a time. For lesson 2, we will be discussing about permutation of n distinct objects arranged in a circle. For lesson 3, we will be discussing about distinguishable permutation. And for lesson 4, our topic will be combination of n taken r at a time. At the end of the lesson, you students will be able to evaluate the factorial of a number, solve problems involving permutation, and solve problems involving combination. Before proceeding to our lesson proper, let's do a short review based on what you've learned on the previous modules. So, first question, what is permutation? A permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matters. Notice the highlight terms, which is order of the arrangement matters. This is the keyword when we're talking about permutation. This is the key formula for permutation, wherein n is equal to the total number of objects and r is equal to the number of objects selected. The formula of permutation of n taken r at a time is n factorial over the factorial of n minus r. Second question, what is combination? A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. Again, notice these highlight words. In a combination, the order of the selection does not matter. And here is the formula of combination, same as n is equal to n, the number of objects in the set, and r is equal to the number of choosing objects from the set. So the formula of combination of n taken r at a time is equal to n factorial over r factorial times the factorial of n minus r. So nabantayan ba ninyo na similar lang ang formula sa combination of permutation, however, there is an additional r factorial in the formula of combination because ang combination gana is the order of selection does not matter. So, wala siya yung difference. Then, let's have a short activity. Permutation versus combination. So, as you can see in your screen, there are several situations depicting permutations on the green side, and there are situations depicting combination on the red side. So, first, some example of permutation: arranging the people digits, numbers, alphabets, letters, and colors. So why do you think this is a permutation? This is a permutation because if we arrange, for example, a digit, the order matters. For example, the digits 1 and 2 is different from 2 and 1 because 1 and 2 can be written as 12 and 2 and 1 is written as 21. So in a way, the order really matters when we arrange them. And on the first example of combination, selection of menu, food, clothes, subjects, and theme. It's a combination because if we select a food or a clothes, it doesn't really matter. The order doesn't really matter. So that is a combination. Second example of a permutation is picking a team captain, pitcher, and shortstop from a group. So why do you think this is a permutation? So this is a permutation because if we pick a certain role for a captain, a pitcher, and a shortstop, in a way there is really an order because every person can have a different role. So for example, I will be chosen as captain, and another arrangement, I will be chosen as a pitcher. So in a way, it is different. And for the second example of combination, picking three team members from a group. So why do you think this is a combination? So as you can see, it is quite similar to an example of permutation, no? Selecting three members from a group. However, in the second example of this combination, it is a combination because there aren't any roles that the members need to fulfill. Meaning, select na sila three groups lang in a certain, three members in a certain group. So in a way, there isn't really an order. So dili gid magmato ang order ani example. And moving on sa third and fourth example of permutation and combination, I will leave it to you to think why these are examples of permutation and combination. So think about it. Now, let us proceed to lesson number 1, which is all about permutation of n taken r at a time. This lesson is written for you to further understand the concept of solving problems involving permutations using the basic counting techniques. So can you still remember the basic counting techniques discussed in Module 1? These are the making a table, tree diagram, basic counting principles, and systematic listing. So always remember that. Since permutation is an ordered arrangement of either all objects in a set or part of such set, so we can say that the order of each element is important. So always remember this. In permutation, order of each element is important. To solve for permutation of n taken r at a time, use the permutation formula, which is this. As what I presented a while ago, the permutation of n taken r at a time is equal to the n factorial over the factorial of n minus r. However, nasa several cases no nga magamit nato ning formula. For example, sa case number 1, the permutation of n taken 0 at a time is equal to 1. Always gina siya equal to 1. In case number 2, the permutation of n taken n at a time, so meaning as a whole na siya, is equal to n factorial. So, kung tanawan ni mga original formula, gikuha lang ang iyang denominator. So, muna siyang n factorial lang ang case number 2. Then, ang case 3, kung nasa yung mga problems ngayon ani, is the permutation of n taken 1 at a time. So, 1 at a time siya, meaning, is equal siya sa n. Sa iyang, kung pila siya, ang total number of objects. So, muna siyang case number 3. So, ayaw niyo siya kalimting nga mga formula because we will be using this formula all throughout the discussion. So, moving on to examples. So, example number 1. Andrea is asked to choose the best 6 out of 10 songs. In how many ways can she choose the top 6 songs? So, as we all know, this problem is already a permutation of n taken r at a time. However, what if lugar wala na siya gi-mention kung unsa ni siya nga problem, unsa gyud yung pagkabalo, then muna siya mangita mo og keyword. So unsa lugar ang keyword aning first example? So muna siya choose the top 6 songs. Bila Andrea is choose the best 6 out of 10 songs. So meaning the order of the songs really matters kay di ba na may top 1, top 2, top 3 up to top 6. So na siya order. Thus it is a permutation of n objects taken r at a time. So, muna siyang type of problem niya. Then, looking at the problem, doon siya yung mga given. So, ang n niya, meaning total number of songs is equal to 10. And r, ikapila siya gipili, is equals to 6. And, of course, we will be using this formula of permutation. The permutation of n taken r at a time is equal to n factorial over the factorial of n minus r. Now, let us proceed to the solving part. The first thing that we need to do here is we just need to substitute the given value of n and r to our formula, making now our solution, the permutation of 10 taken 6 at a time is equal to 10 factorial over the factorial of 10 minus 6. Then, the next thing that we need to do is we subtract the denominator. So, making our solution now 10 factorial over 4 factorial. So, what is the next thing that we need to do? So, as we all know, a factorial is the product of numbers less than or equal to the given number. So, what do we mean by that? For example, kaning 10 factorial, mahimo din ni siyang 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Same as kaning 4 factorial, it will become 4 times 3 times 2 times 1. So basically, this is how factorial works. The next is, we will be canceling this part because as we all know, rule of division, a number divided by itself is equal to 1. So it will be, in a way, it will be cancelled because it is now equal to 1, making now our solution 10 times 9 times 8 times 7 times 6 times 5. And then you might be asking, sir, asa ang 1? Na di ba rule ang multiplication nga a number divided by a number multiplied by 1 is equal to itself. So meaning kung i-divide natin si 10 times 8 times 7 times 6 times 5 sa 1, same ra gyapon siya. Mo na siya ang rule sa multiplication. So now, i-multiply na natin ni sila. So 10 times 9 times 8 times 7 times 6 times 5 is equal to 151,200. Therefore, Andrea can choose the best 6 out of 10 songs in a 151,200 ways. Moving on to the example number 2. In how many ways can 7 boys of grade 10 choral sit in a row of 5 chairs? So same thing that we did in example number 1, we need to find a keyword. Nga ano man good permutation ni siya. So ang keyword ani example number 2 is sit in a row of 5 chairs because the order of the boys sitting arrangement matters. So mo siyang permutation siyang nga type of problem. Next, what are the given? So ang n nato siya, our total number of boys is 7. Then ang r is equal to 5 because mora man na siya ang 5 chairs ang maingkuran sa boys, meaning 5 boys lang ang makaingkod. So next, we will use the formula of permutation. Yapon nga, permutation of n taken r at a time is equal to n factorial over the factorial of n minus r. Moving on to the solving part, just substitute the value of n and r to our formula, making our solution the permutation of 7 taken 5 at a time is equal to 7 factorial over the factorial of 7 minus 5. Then, we subtract the denominator. 7 minus 5 is equal to 2, making our solution 7 factorial over 2 factorial. Then, computing the factorial, 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is equal to 2 times 1. Same as what we did, we could cancel out 2 times 1 because 2 times 1 over 2 times 1 is equals to 1. Now, our solution is equal to 7 times 6 times 5 times 4 times 3. And multiplying these numbers, the product is 2,520. Therefore, there are 2,520 ways that the 7 boys of grade 10 choral can sit in a row of 5 chairs. Now, we will proceed to lesson number 2, permutation of n distinct objects arranged in a circle. So basically, this is a circular permutation. In this lesson, solving problems involving n distinct objects arranged in a circle is well emphasized. To further understand the concept of solving problems involving permutations, specifically circular permutations, use the given formula. P is equal to the factorial of n minus 1. So, kani siya nga formula ang inyong gamiton if a problem is circular permutation. For example, in a group of 9 tele teachers at MOGS, in how many ways can they sit in a circular meeting? So, saan lugar ito pag-determine ng circular permutation ita? So, ang keyword aning anong circular permutation siya nga problem is ang word nga circular meeting because the arrangement is circular and the order matters. So, mo siyang circular permutation. So, the type of problem, permutation of n distinct objects arranged in a circle. Then, ang given niya is 9 teleteachers. Thus, our n is equal to 9. And then, we will be using the formula of circular permutation, which is p is equal to the factorial of n minus 1. And in order to solve this problem, we just need to substitute the given to our formula. Muna niya siya nga ito ang solution. P is equal to the factorial of 9 minus 1. Then, we'll be subtracting 9 minus 1. 9 minus 1 is equal to 8 factorial. So, muna po siya nung. So, ang ito pag-factorial, we just need to multiply 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So, muna siyang equal niya sa 8 factorial. And if we multiply these numbers, sige, multiply ninyo, ang iyang product is 40,320. Therefore, there are 40,320 ways that the group of 9 teleteachers can sit in a circular meeting. Moving on to example number 2. Hizam and Clarice wants to plant some shrubs around a circular walkway. They have 7 different shrubs. How many different ways can the shrubs be planted? Same as what we did, we need to find the keyword. So, ang keyword lugar ani para nga makaingon ta nga circular permutation ni siya. Ang keyword ani is the circular walkway. Mo na siya makaingon din kang it is a permutation of n distinct objects arranged in a circle. Then, what are the given? What is the given? Ang given, di ba, there are how many shrubs? 7 different shrubs. So, mo na siyang n is equal to 7. Then we will use the same formula. P is equal to the factorial of n minus 1. Then, we just substitute the value of n to the formula, making now our solution, P is equal to the factorial of 7 minus 1. 7 minus 1 is equal to 6. So, thus, our solution now is equal to 6 factorial. And 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And if we multiply these numbers, our product will be 720. Therefore, Hizam and Clarice can arrange the 7 different shrubs in a circular walkway 720 ways. Now, let us proceed to our lesson number 3, which is all about distinguishable permutations. So in this lesson, you will learn to solve problems involving distinguishable permutations. These are word problems related to real-life situations with repeated symbols and restrictions or special conditions. Mo na siya nagitawag na distinguishable permutations. To further understand the concept of solving problems involving permutations, use this formula. P is equal to n factorial over n sub 1 factorial times n sub 2 factorials times n sub 3 factorials times up to n sub k factorial. So meaning, pila ka buok ang iyahang condition. So n sub kung isa lang ka condition, n sub 1 lang. Kung duha, n sub 2 and so on. So to further understand this formula, we will be proceeding to the first example. Example number 1, how many ways can we arrange the letters of the word mathematics? So, ano makaingon maka nga distinguishable permutation siya? Pangita na to ang keyword. Ang keyword is arrange the letters sa mathematics. Ano to ang word nga i-arrange mathematics. As you can see, na ay repeated elements sa mathematics no, na ay mga word letters nga gibalik-balik. So thus, makaingon ta nga kani siya is distinguishable permutation. Then tanaw to ang given. So, how many ang total letters? So, imong i-count ang letters sa mathematics, there are 11 letters all in all. Then, next is we need to find the different numbers o kapila gibalik-balik ang each letter. So, for example, n sub 1, that is our m, letter M. Then looking at the word mathematics is gibalik siya twice. So next, our n sub 2, letter A. Nato siya kung when we look at the word and the word mathematics, it was the letter A is repeated twice. And also, our n sub 3, which is letter T, it is repeated twice. Our letters H, E, I, C, and S are all just appears once. Muna siya itong isulat. So, basta magdibog mo ba nga, masa man ang n sub 1, n sub 2, kanya siya is, gidenote lang siya nga, ang n sub 1 is M, n sub 2 is A, and so on. Pwede mo ma-rearrange niya siya nga, n sub 1 si A, n sub 2 si M, and so on. Kanya siya, ako lang siyang sunod-sunod. So, muna akong assign nga n sub 1 si M, and so on. So, kung kamo gusto mo nga lain, is you could lain nga letter si n sub 1, lain nga letter si n sub 2, kamo bahalaan na. And then another question, basta mga tanong mo nga nganong n sub 8 taman, kay kung dili ibalik-balik ang letters, 8 lagi siya kabuok, letter M, A, T, H, E, I, C, S. Pero if atong siya po ng all letters nga masing ibalik-balik na siya 11, mo ng n is equal to 11. Then, we will be using the formula that I mentioned a while ago sa distinguishable permutations. P is equal to n factorial over n sub 1 factorial times n sub 2 factorial times n sub 3 factorial, and so on. So, since ang ato ang, as you can see in our given, n sub 8 man siya, no? So n sub 8 dito taman. Pero, kung imo siya tanawon pod, nga ang 1, ba 1 multiply ka og number sa 1 is mo ang number mo gid sa 2 times 1 2, di ba? 3 times 1 ang 3. So pwede na to, dili na to i-appel na dayon ang mga ones lang nag-repeat. Ang atong i-include lang sa formula is ay sa solution is katong mga more than once nag-repeat. As you can see in this scenario, na 3 letters ang nag-repeat twice, which is letters M, A, and T. So, mora na siya itong gisulat nga P is equal to 11 factorial over 2 factorial times 2 factorial times 2 factorial. Kaya kung magwatang patag 1 factorial na siya, more redundant na siya, unnecessary na dahil siya kay mora magyapon siya i-multiply na to ang 1 is di gyapon magbago ang solution. So, muna siya muna natang gibuhat. Then, next, 11 factorial is equal to 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Then 2 factorial 2 times 1. So since naman tayo tulo ka 2 factorial, so muna siyang 2 times 1 times 2 times 1 times 2 times 1. So always remember na kani siyang open and close parenthesis bitaw, gidenote na siya og multiplication. So nang wala na ako nagbutang og multiplication sign sa in between them, kay pasabot ang na siya is multiplication na gyapon. Pwede na siya redundant tan-awon. Then we can, kung makiano yun, di ba na ay 2 times 1 sa upper sa numerator, na po 2 times 1 sa denominator. Thus we could cancel them out because if we divide a number by itself, 1 man gid siya, no? So then, i-multiply din na to. 11 times 10 times 9 times 7 times 6 times 5 times 4 times 3 is equal to 19,958,400. Then, ating i-multiply ang denominator. 2 times 1 times 2 times 1 is equal to 4. Then, last step, we divide them. So, divide the numerator by the denominator. So, if we divide 19,958,400 divided by 4, the quotient is 4,989,600 ways. So mo na siya ang atong ma-arrange ang word nga mathematics. Now, let us proceed to our last lesson, which is the combination of n taken r at a time. So no, ang previous 3 lessons are all permutations. Kani siya is, atong last lesson is about combination, na meaning ang order sa given or elements does not really matter sa atong mga example. So in this lesson, As what I've said, the order of the object does not matter, only its arrangement. Solving problems involving combination of n objects taken or at a time is a given emphasis. To further understand the concept of solving problems involving combination, use the given formula as follows. So the combination of n taken or at a time is equal to n factorial over the factorial of n minus r times r factorial. So don't forget this formula. For our example number 1, at the MacArthur Park, an ice cream in a cone is sold. In how many ways can Joshua choose his 3-flavor ice cream scoop if there are 5 flavors available? So the keyword here is choose his 3-flavor, meaning the order of flavor does not matter. Therefore, the type of problem is a combination of n taken r at a time. So muna siya ang inyong pangitaan niyo ang keyword and mo para makadetermine mo sa siya nga type of problem. Muna siya, dapat you must not forget this step. Kay what if lugar mali inyong gamiton nga formula lugar. So sayo po na inyo ang answer. So pangitaan din niyo sa ang keyword ay din niyo ma-determine para ma-determine niyo sa siya nga type ng problem. Then our given the given here in this problem is n is equal to 5. Ibang mo siyang total number of available flavors sa ice cream. And our r is equal to 3 because Joshua only need to choose 3 flavors. So mo siyang r is equal to 3. Then our formula as mentioned earlier, the combination of n taken r at a time is equal to n factorial over r factorial times the factorial of n minus r. So, nalibog mo ba nga, hala, tunggan nilagay ang r factorial, kaya na siya sa last part. So, pwede rin na siya ma-interchange in a way because multiplication man na siya no, and according to the commutative property of multiplication, pwede rin natin mabaylo-baylo ang terms. Wala, di siya mag-differ ang answer. So, muna siya. Moving on to the solving part, i-substitute lang nato ang given problem, the given sa atong formula. Making our solution now, the combination of 5 taken 3 at a time is equal to 5 factorial over 3 factorial times the factorial of 5 minus 3. Then at na i-subtract si 5 of 3. 5 minus 3 is equal to 2. Now our equation is equal to 5 factorial over 3 factorial times 2 factorial. And then, ato na itong i-compute factorial, ato yung i-compute ang factorial. So, 5 factorial is equal to 5 times 4 times 3 times 2 times 1 over 3 factorial is equal to 3 times 2 times 1 and 2 factorial is equal to 2 times 1. As you can see, we could cancel out 3 times 2 times 1 both in numerator and denominator because kung i-divide natin sila duha, ang equal nila is 1. So, ang ma-remain sa ito ang problem is 5 times 4 over 2 times 1. And 5 times 4 is equal to 20 and 2 times 1 is equal to 2. Then, the next step na itong buhat na ani is we will be dividing 20 and 2. So, 20 divided by 2 is equal to 10. Therefore, Joshua can choose his 3-flavor ice cream scoop out of 5 available flavors in 10 ways. So, move na ta sa second example. During the intramurals, how many ways can a volleyball coach choose the first 5 players from a group of 20 grade 10 students? So, ang keyword ani is choose the first 5 players. Ngano man kani siyang keyword because the order of players does not really matter. Therefore, it is a combination. Ang type of problem is a combination. And ang given sa problem is n is equal to 20. Kaya ang total number of students kay 20. And r is equal to 5 because the coach only need to choose the first 5 players. So, mo na siya ang atong given. Then, same formula. The combination of n taken r at a time is equal to n factorial over the r factorial times the factorial of n minus r. Then, substitute the given value to our formula. So, the combination of 20 taken 5 at a time is equal to 20 factorial over 5 factorial times the factorial of 20 minus 5. Then let us subtract 20 and 5. So 20 minus 5 is equal to 15. Therefore, our solution now is 20 factorial over 5 factorial times 15 factorial. So let's compute this factorial nga kung ano. So 20 factorial is equal to 20 times 19 times 18 times 17 times 16 times 15 times 14 up to times 1. Over 5 factorial is 5 times 4 times 3 times 1. And 15 factorial is equal to 15 times 14 times and so on, palulong sa 1. So as you can see, we could cancel out the 15 times 14 times 13 times 12 and so on, taman 1, because we can both find them in the numerator and denominator. Pag i-divide natin sila dua, ang answer nila is 1. And so ang atong remaining problems are 20 times, ang remaining nato sa atong solution is 20 times 19 times 18 times 17 times 16 over 5 times 4 times 3 times 2 times 1. So we will multiply these numbers na kayo. Multiply na ito ang numerator. Ang product is 1,860,480. Then, pag i-multiply na ito ang denominator, ang 5 times 4 times 3 times 2 times 1, ang product is equal to 120. Then, last step, i-divide na ito. 1,860,480 divided by 120 is equal to 15,504. Therefore, the coach can choose the first 5 players from a group of 20 grade 10 students 15,504 ways. And that concludes our discussion for the 4 lessons of Module 5. Now, let us proceed to the exercises. So, direction, solve the following problems and identify whether the following situation depicts permutation or combination. So again, solve the following problems and identify whether the following situation depicts permutation or combination. So you can pause the video so that you have a ample of time to answer the different questions. So let us start. Number 1. How many ways can 5 officers in grade 10 Jade class be elected among 45 students? Again, how many ways can 5 officers in grade 10 Jade class be elected among 45 students? You could pause this video so that you could answer it. The answer is 146,611,880 ways, and it is a permutation. Number 2. There are 8 boys in a basketball team. In how many ways can the coach make a selection of 5? There are 8 boys in a basketball team. In how many ways can the coach make a selection of 5? The answer is 56 ways, and it is a combination. Number 3. How many arrangements can you form in a carousel with 12 children? Again, how many arrangements can you form in a carousel with 12 children? The answer is 39,916,800 ways, and it is a permutation. Number 4. Find the numbers of different ways of placing 6 marbles in a row given that 3 are blue, 2 are green, and 1 is black. Again, find the numbers of different ways of placing 6 marbles in a row given that 3 are blue, 2 are green, and 1 is black. The answer is 60 ways, and it is a permutation. Last number, number 5. In serving a breakfast meal, in how many ways can Roland choose his 4 viand meal if there are 8 available dishes? Again, in serving a breakfast meal, in how many ways can Roland choose his 4 viand meal if there are 8 available dishes? The answer is 70 ways, and it is a combination. And that is our exercises for today's video. Congratulations to those who participate and got the correct answer. So this will be our assessment. For Module 5, if you prefer to answer the test online, access this Google Form link as you can see in your screen. So remember, you don't need to submit a hard copy of your answer sheet for Module 5 if you answer this online. However, if you don't want to answer online, use the answer sheet and answer the following in Module 5. Lesson 1 assessment, Lesson 2 assessment, Lesson 3 assessment, and Lesson 4 assessment. So that's all for today's video. Thank you so much for listening, and if you have any questions with regarding to this topic, don't hesitate to contact me through my messenger account or through my email or phone number that I have said a while ago. Thank you for listening. Goodbye.